Hey guys, Interchange here. So it's the second day of my GANs journey, and yesterday I read the original paper on GANs and I benefited from that a lot. So it's probably time for me to implement the GANs myself. However, GANs seems a little bit hard to implement because there's like first of all it's like two neural networks, and then one of the neural networks has to so the generator has to feed its output into the detector. Or the discriminator. So I think that's a little bit hard for what my coding skill has to show right now. So I think I'm still gonna follow a tutorial or two, and then maybe implement the GANs for anime face generation myself. So yeah, that will be what I'm going to be doing today. So I don't think it's training on my GPU, and that's a little bit weird. So I'm just gonna cancel the process. And I really don't know why, but how to verify if keyrest is using GPU. So printing from the console in Spider says that it seems like we are using GPU, but I'm guessing that if I run stuff in the terminal, I'm not using my Conda environment, and in Conda I might have installed the keyrest GPU, but when we move outside of Conda, we're using pip and stuff like that, and I'm afraid that even though I'm pretty sure I'll also use pip install keyrest GPU or TensorFlow GPU, it doesn't seem like that I'm using it. So I think I'm just gonna run everything in the console then instead of in the terminal. So yeah. So that was a lot of time wasted, but it's okay. I wasn't doing anything. Guys, welcome to the GPU world. So let me summarize what I just learned. If I were to call stuff in, so I have set up a lot of my Python packages in Conda, since it seems really intuitive for beginners or even pros. Because Conda provides a lot of services. For example, the IPython console, it binds with the IDE Spider, and you can download a lot of packages in Anaconda. So for example, Keras and TensorFlow GPU. And what I did earlier that this allowed me to run on my CPU was that I was running a terminal. And when running a terminal, we're not in the Conda virtual environment, which means I didn't download TensorFlow GPU in outside of the Conda environment, it appears. So when I do run it inside of the actual Conda environment, everything works because it has the TensorFlow GPU package installed, probably. So that's all good, and it's training a lot faster now, as you can see. So that's good. Now I'll just come back later. So
saw that thing so beautiful. She just hit my heart, oh. Full force and she got me like, I be like, why you so
Okay, so that was it
fine?
actually. I think that was it.
Gotta make you
Um,
so hard to find. They be like, oh, how'd you do the thing? The way that you do it is
so then we can see that on the fourth epoch, this is the stuff that is generated. I'll be training this over 100 epochs then.
so heaven sent. I think she was
So to
meant
do that, I think all I gotta do is this, and then so our generator is 25.8 megabytes right now. I mean, even if I do 100 epochs, it's still going to be the same thing because it's the waste that is changing. It's not going to be increasing in size, I think. And my discriminator is smaller, and I think that makes sense, right? Okay, so let's get it going. Man, honestly, just seeing the GPU doing work is the most exciting part of machine learning. Ah, feels so good.
so sublime, super fine. She was never lying, strutting in the heels or her slides. Either way, eyes on her every single day, week, year. Everyone wondering how she does it with no fear. All that confidence, was it
Hey guys,
heaven
so
sent? Does it come within?
the model
Does
has
it come
finally
from
finished
out?
training.
I don't
As
know.
you can see
She'll
here,
just have me running
so
out
really
there.
in the GAN,
Everyone
we don't really care
dissing,
about the
talking
discriminator at the end, right? We only care about the generator. And the discriminator is only complementary to the generator because it helps the generator grow and get better. So it's really this generator and this 25.8 megabytes file that we really care about. So, I've done the training. So now all I gotta do is to run this generate and then give it a batch size. And then when we hit run, it's going to save it to a generated image.png and then we can look at it. And look, that is pretty nice, I gotta say. Right, like that data right there, to me it looks pretty realistic. There is a few ones that are not the best. For example, this one. I don't know if you can see, it looks like opposite 7. But besides that one, there are a few ones that doesn't look exactly like 0. But, it can get better. Yeah. So that's really interesting. So now it's actually time for me to go back and learn exactly, what kind of functions and why do we call this exactly. Um, you know, so it's time for me to actually go back now and learn the code that I copied. What does it mean? So yeah. Alright guys, so after reading the code and really making sense of what the syntaxes mean, I think I do have a better idea of what is going on. So again, the generative adversarial network has two parts, a generator and a discriminator. So a generator is going to output, an actual image, and the discriminator is going to output a value or a constant that is fed through a sigmoid activation function. Right, because the discriminator is trying to again predict how likely the input is coming from the original distribution. So yeah. Now I guess generator itself makes sense. This is a DC GAN, so we do implement some sort of image, make convolutional network in there. So that makes it a little bit more complex, and I guess that the generator can better learn what kind of weights to put onto the noise image in order to get
to get a better output that a discriminator cannot discriminate against. The part that definitely tripped me up is always for me personally, is always the like whenever I see just all these native Python functions or NP functions like yeah, like whenever I see dot shape, dot whatever, indexing arrays, I just get really confused. So personally, I always like open a new file and just print out what the actual data looks like. So then like if I look at xtest, like or if I just know the size, it makes me a lot more comfortable because I know what is going on. So if it's 10,000 by 28 by 28, I know that there's going to be 10,000 training examples, and each training example is 28 by 28, which is the size of the image. So that makes sense. And the interesting thing that stuck me for a while was how do we exactly get the loss? Because I saw this right here. The discriminator loss is based on x and y, and then I'm like, okay. But then again, I'm just so not familiar with these native Python functions that when I saw np.concatenate, I thought that it means adding them together, but I didn't know that it means really just adding the generated images to the end of the array that image batch is in, and y is basically so. And then when you do this like array, a rank 1 array times a number, it's actually not going to give you like return 128 in a single array. It actually returns this thing right here. So, and then like that, when that happened, everything makes sense intuitionally, because you know image batch is supposed to be the real image, so then the labels for them should be 1, and then generated image is fake, so its labels should be 0. So then we train on that data set, and then that just made a lot of sense to me. The same thing for the G loss, although, and then it also helps just really you know, opening up again a new file and just computing what G loss is, so you get like better intuition. So I actually see a value, so you know I get that kind of intuition of what G loss is really about. This one, to be honest, still doesn't make sense to me, because like we are making new noises every time, and even though that noise is uniform, so which means that whenever you generate it, all of it together, adding all of the blocks in the array together will compute the same value every time. It just doesn't make sense to me how like this generator is so flexible that whatever kind of uniform noise it inputs is going to output a pretty good image. So that got me kind of confused, and I have no idea why the labels for them are 1. I just really don't get the noise part, to be honest. Like, I don't get the noise that why we're changing the noise every time and such. But yeah, and I looked it up on whatever, so it doesn't make sense. But honestly, I learned a lot today. I really learned the following. I really learned that I need to get the basics down, and that whenever I see something that doesn't make sense, make sure to open up a new file and just run it independently, so I can see in the variable explorer, and everything is going to make sense then. So yeah, again, so I learned a lot today, and I think that's it for this video. And in the next one, I think I will be implementing the actual anime faces. So there shouldn't be that many changes. The input variables can be really flexible. So yeah, we'll see. Tomorrow is gonna be a great day. So see you guys later.